All right, today's lesson is on solving radicals and rational expressions or rational exponents. So we're going to start by taking a look at how you convert between rational exponents and radical form. I do want to be able to draw a relationship between square roots and fractional exponents. Square roots and fractional exponents. For example, if I have x and I have the square root of x, I guess my board's a little slow. Here it comes. All right. What's understood, I hope, is that there's actually a little 2. That's called your index. Sometimes we just call it the root. Okay, so the index or the root. Inside, that's understood to be a power of 1. Okay, so I can express square root of x with a power and inside of 1 and an outside index or root of 2 as x to the 1 over 2 power, and I get x to the 1/2. All right, so x to the 1/2. What I can do is we can actually look at that on our calculator. So I've pulled up my calculator, and let's just say that we ask ourselves about, let's just say the square root of 25. We know that the square root of 25 is 5. We also, once we realize the relationship between a square root and a fractional exponent, is that 25 would be to the 1/2, because that would be, again, an index or a power of, root of 2, and that's 25 to the first power. So that would be 25 to the 1 over 2 power. That should also give me 5. So if we check on our calculators, we would say the square root of 25 is 5. Or 25 raised, and I don't have an old calculator here, to the 1 divided by 2 or 1/2 power is also 5. So I'm hoping that you'll make that connection between a square root or a radical and also your exponent. Now what happens is that can also apply for other powers. So what if I was to consider the fact that 8 times itself 3 times, 2 times itself 3 times, is trying to stick with easy examples, is 8. All right, so that's actually 2 to the 3rd power equals 8. What if I took the 3rd root, and if it's anything other than a 2, you have to put the 3 there. So I'm going to take the 3rd root of 8. The 3rd root of 8, the number times itself 3 times its 8, is 2. Or I could say that's 8 to the 1st power over an outside index of 3. 8 to the 1/3 power should also give me 2. And let's see if we can do that on our calculators. All right, pulling up the calculator. If I take 8 and, let's clear that. I'm going to take the 3rd root. Now if I press the math key, I see that number 4 is actually the 3rd root, so I'm going to press for the 4th option, and you see the little 3 out there. It's going to be the 3rd root of 8 is 2, or 8 raised to the 1 divided by 3 power is also 2. So that applies for any relationship between the square root being a 2nd root, the 3rd root being a 1/3 power. All right, let's now look at our notes. Same thing that I just had there is expressed in notes. This is just a way so that you can see. So if I have a to the m over n, that's a fraction, then that means m is the inside power and n is the outside root. Or it can also be m on an outside power, but it still has an n root. You can say it's the exponent over the index. That would be correct terminology. Or a lot of times we will look at this version. It's the power over the root. So just have notes, a visual way for you to see it. And we're just going to try to introduce this today. So I'm going to take and rewrite in every expression in radical form. So the first thing I look at is the bottom says that the root is 2. So I'm going to take the square root or the 2nd root. If it's the square root, you technically don't need the 2 there. The top is the exponent. So I'm going to take 10 to the 1st power, or that's just the same as square root of 10. So 10 to the 1/2 power is the same thing as square root of 10. 6 to the 1/3 power. The bottom number is the root, and the top number is the exponent. So I'm going to take the 3rd root. You have to put a 3 there. 6 to the 1st power, or the 3rd root of 6. Okay, 3rd root of 6. Next one, b to the 3/2 power. Again, the root I'm taking is square root, so it's just square root. b is the thing that goes inside, and the exponent on the b should be a 3. That's the square root of b to the 3rd. Example 4. All right, it's a little tricky. I want you to pay attention. What is the closest thing that the exponent touches? The closest thing the exponent touches is the x. That means that the exponent only goes with the x. 20 does not go with the exponent. So I'm taking 20 on the outside. The bottom number is a 6, so that tells me that I'm taking the 6th root. So I'm going to put a 6 right here. I'll make sure we can see it. And then it's going to be x, and the outside exponent, or the exponent, is a 5. So that is the correct way that I would rewrite 20x to the 5/6 power. It's the same thing as 26th root of x to the 5th. Rewrite each radical expression in a rational exponent. So now I'm giving it to you basically in the opposite form. We don't have to simplify. We're just trying to practice rewriting things. So I am taking the second root, so there's implied to be a 2 there. Sometimes I will say inside over outside, or power over exponent, or exponent over root. That's x to the exponent over a root of 2, x to the 5/2. That's 15 to the 1st power, inside over outside, 15 to the 1/4, or exponent over root. Okay, this time the exponent's outside, but it still counts. It's just like what we saw up here in our notes. Sometimes the exponent can be on the outside, but it's still an exponent. So I also have 2x, and because the exponent goes with a 2 and the x together, I do need to use parentheses. Inside is 5, outside is 3, or exponent over root, 5/3. 7, 6th root of 7 is 7 to the 1/6 power. All right, that's just a quick introduction and a brief introduction into fractional exponents, or what we call rational exponents, and how we can switch back and forth to radical form. All right, now let's go on to another part of our lesson. The second part of our lesson is solving radical equations. Here's our strategy, 2 things. Get the radical by itself, square both sides of the equation. Some of the first ones you could almost solve for these maybe just by looking at it, just by taking a quick look. I'm basically saying what number could go inside the square root for x, and after you take the square root you get 6. Some people will say, hey, that's 36. And I hope that you do see that it is 36. But if we follow our strategies, the first thing that we would do is say, okay, get the square, or get the radical by itself. The radical is already by itself. The second thing we're going to do is square both sides, because if I do that to one side, I have to do it to the other side. When you square both sides, the square root and the square cancel each other, and whatever was underneath just comes out. So I get x, and 6 squared is 36. So you can work it out and get 36, or you can reason it out and also see that it's 36. All right. In my strategy, I'm trying to get the radical by itself, which is the square root with an m. How do I get rid of 3? Got to subtract 3 first. Now I have square root of m is equal to 10. Again, you can reason this out. What number underneath the square root would give me a 10? All right. You square both sides, and I think you can see, because the m comes out, m is equal to 100. 100, the square root of 100, does give you 10. Okay, look at our next 2. Okay, trying to get the radical by itself. We do have that, so the radical is already by itself. Next thing, after you get the radical by itself, is square both sides. All right, when you square both sides, the square root and the square cancel, and everything that was underneath the square root comes out. So the 2 and the y both come out, equal to 4 squared, 16. Still not finished. I got a little work to do. Divide by 2, and y equals 8. So if I come back up here and I were to put 2 times 8, I'd get 16. Square root of 16 does equal 4, and that would actually show that my answer does work. So you can always go back and ask yourself if your answer works. Number 4, if I try to get the radical by itself, this is the only part that you would actually call the radical. So it means I need to get rid of the 2. How do I get rid of the 2? Well, I'm going to divide the 2. If I divide one side by 2, I divide the other side by 2. Now I just have the radical with x in it equal to 4. And now some people will be able to say, oh, what number under the square root is going to give me a 4? Taking the square of both sides, I get x is equal to 16. Again, once you get it to a form when you can reason it out and you see the answer, you can just give the answer. Okay, number 5. We're getting progressively more and more things that we have to consider. Now I have an expression under the radical, but this is all still just considered the radical. So step number 1, I need to get the radical by itself, so I have to get rid of minus 5. I'm going to add 5. Okay, now I have the radical with 4m plus 1 in it equal to 5. Now what I want to do is I'm going to square both sides, and I'm squaring the entire thing. So the entire square root cancels with the square, and everything that was in there comes out. So the 4m plus 1 comes out, 5 to the second power, 25. Now I have a little equation with no square roots that I should be able to solve easily. Minus 1 from both sides, 4m equals 24. Divide both sides by 4. M should equal 6. Okay? It's got a couple more to go. Now we have some fractions. All right, let's just see if we can handle these. All right, now the square root goes over the x and the 3, but that's the only thing I have on this side, so I already have the radical by itself. Even though the radical does have a fraction, it's still everything's under there. So what I need to do is I'm going to go ahead and square both sides. All right, the square root and the square cancel each other, so what was underneath there comes out. So x over 3, 2 to the second power becomes 4. Now I have to ask myself, this time my x is divided by 3, so how do I get rid of divide by 3? I should times by 3. So if I times by 3, my 3's cancel. If I times this side by 3, I times this side by 3, and my answer should be 12. So 12, if I were to substitute 12 back up in here, 12 divided by 3 is 4, and the square root of 4 would give me 2. So just kind of checking to see if the answer works, and it does. All right, first thing I need to do is get the radical by itself. So I need to get rid of minus 4, so I'm going to plus 4. When I do, I get the square root with 3x over 5 inside equal to 6. Okay, because the square root goes over everything. So now that the square root's by itself, square this side and square that side. The square root and the square cancel, so everything that was under the square root comes out. 3x minus 5 equals 36. Now, how do I deal with a fraction? The easiest way might be just to think of it one thing at a time. I've got 3x divided by 5. So let's first of all imagine how would I get rid of divide by 5? Well, I'm going to times by 5. So if I times this side by 5, I'm also going to times that side by 5. Okay, what I have left over here is my 3x. And over here, 36 times 5, I believe, is 180. Now we're down to something that looks more familiar. We're going to finish by dividing by 3, and I believe our final answer is x is equal to 60. Okay, I think just a couple more to go. All right, number 8. Again, trying to progress as we go, looking at different problems. I have, first step, get the radical by itself. Well, technically, I do have 2 radicals. I have this radical by itself, and on the other side, I have that radical by itself. So I actually have done step 1. So let's go ahead and proceed to step 2. Step 2 is square both sides. If you square both sides, square and the square root cancel. Square and the square root cancel. So everything that was comes out. So 3x plus 5 comes out when I square it. Over here, 5x minus 13 comes out when I square it. And now I have a problem where I have an x on both sides, numbers on both sides. I like to keep my x's positive, so I'm going to subtract 3x and take it over there. So now 3's gone. I'm going to add 13 and take it over here. Now the 13's are gone. And what I end up with is 5 and 13 is 18. 5x minus 3x gives me 2x. And finishing by dividing by 2, x is found to equal 9. All right? X is equal to 9. So that strategy, I had a square root on both sides. I squared both sides to begin. Number 9, this is our last example on our sheet. And first thing it says is get the square root by itself. Well, I have 2 square roots, just like I had in the last problem. But the thing is, they're on the same side. Can't really work with them as easy when they're on the same side. So I need to move one to the other side. So this says minus 3 square root of x plus 2. I can move this entire thing over there if I add 3 square root of x plus 2. So I'm going to add 3 square root of x plus 2. When I do, I get a square root on the left and 3 and a square root of x plus 2 on the right. I have at least done everything I can to try to get the radicals by themselves. Now, second step is square both sides. When I square both sides, this one has an extra 3. But it's only legal to square both sides is if you square everything on both sides. So I'm not going to leave out the 3. The 3 has to be squared also. So when I square a square root, this one just gives me 2x minus 7 in it. If you square the 3, like I said, you can't forget it, you end up with 9. Here, the square root and the square cancel, so I get my x plus 2 back. But we need to remember that 3 was multiplied by the x plus 2, which was together inside the radical. So what do I need here in order to make sure that I know 9 is multiplied by everything? Keep that in parentheses. That's very important because it was 9 times this. Not just 9 times x, not 9 times the first one, but 9 times everything. So make sure you use parentheses. All right, we do need to distribute the 9, and I'd get 2x minus 7 is equal to 9x plus 9 times 2 is 18. Again, x is on both sides of the equation, so I'm going to subtract 2x. All right, 2 x's are gone. I'm going to subtract 18. All right, I get 9x minus 2x is 7x. Negative 7 minus 18, both are negative, so I'm going to add and keep it negative. Turns out to be 25. This does not work out evenly, so I'm going to leave my answer as a fraction. Divide by 7 on both sides. X is equal to negative 25 over 7. Fractions can still be considered the final answer. And that's your notes for solving radical equations.